In this video, I'd like to talk about these auxiliary IR illuminators for CCTV or surveillance cameras, however you want to call them. The IR illuminators really quite useful in various situations. First of all, your camera may not come with LEDs in it. Some don't, most do, but the situation that I found is I wanted to illuminate various areas in my field of vision for my camera that were not illuminated by the LEDs in the camera. So that's why I've mounted a number of these. Out of my 10 cameras around my house, I have 5 LED illuminators mounted. And I'm using a 4 LED illuminator. Just comes in a package that looks like this. I've got the couple of lenses out of this one. But they also come in various other configurations. For example, here's a 8 LED, and I've seen them 6 and various other configurations, but they're all pretty much going to be the same. Let me talk just briefly about why you might want this illuminator. Not particularly this illuminator, but any illuminator. The field of vision on my cameras is 94 degrees, so it's a little bit more than a right angle. Well, the LEDs that are built in the camera pretty much light up, an area like this, right in the middle of the field of vision, which works pretty good in most cases. But I have a situation where, for example, this is my driveway, and I want to mount the camera over here in the corner. Well, this ends up being just illuminating the middle of my driveway, but over here where my alley runs I get almost no light into the alley. And especially since I have my camera set on motion, people can walk down the alley and never set off my camera, even though they're actually in the field of vision of the camera. It's simply because there's not enough light at night. So I took and mounted one of these IR illuminators here on the back of my garage, and it shines, basically this way into the alley. And so now anything or anybody going down the alley sets off my camera, and I can get a really good view of them. So that's just an example of why you might want an auxiliary IR illuminator. My neighbor, for example, has a camera that the illuminators burned out on, and so he just, rather than repair the camera, he put up auxiliary illuminator. So they can be quite useful. Now, these particular illuminators that I'm purchasing, these run in the 850 nanometer range, which means they have a slightly red glow to the LED. If you're looking directly into the illuminator, you'll see the red glow of the LED, but you won't see the light itself, because 850 nanometer is considerably outside the human range of vision. The illuminators, of course, do come in visible light. They also come in higher frequency light that is completely invisible to the naked eye of a human. The LED itself won't even glow. So those are like up in the 920, 950 nanometer range. You can also buy these in the 720 to 750 range. Now those are going to be quite red. The 850 is probably the most common that you're going to find, but if you really want to be discreet, covert, however you want to say it, with your illuminators and your cameras, well, you need to get above 850 nanometer to make the illuminator completely invisible. I'll talk about this in a second. Okay, so what happens on the illuminators that I've been having issues with is, out of the I've purchased 8 illuminators, because out of the original 5, 3 of them failed, and they failed within 1 month to 3 months. So that's not good. The problem really is a heatsink issue, which I've resolved. I've got, now that I've repaired these, the illuminators, the 5 that I have up, they've been operating over 2.5 years and had not failed since. So I'll talk about how to replace the burned out illuminator. But let's go with the circuit first, just a little bit, so that you understand what's going on. This integrated circuit right here is the guy that does all the work. It provides constant current to the LEDs on this board. And I've traced out that circuit. It looks like this. And I'll put a link down in the video description for this schematic. But what you're going to find that's typical of all of these, and they did not come exactly like this. Out of the 8 total illuminators that I purchased, I got several different versions of this, but they were very similar to one another. For one thing, the LEDs are in series. Now in that other illuminator, this one right here, it has 8 LEDs, and all they did there was, it's an identical circuit. They just add another 4 LEDs right along in parallel with the original 4. So you've got 8 LEDs, 4 and 4 in parallel, which doubles the current on this guy. Now the ones that I purchased came basically in 2 different amounts of current going through the LED. The most common seems to be around 700 to 750 milliamps. And then the others I purchased were around the 500 milliamp. So considerable difference in the amount of current going through the LEDs. Now, of course, the 500 milliamp were not nearly as bright as the 750 milliamp, and that's to be expected. If you wanted to, as I did, I wanted to make all of mine as bright as possible after I figured out how to heat sink these guys and stop the failures. Is on the board there's 2 resistors in parallel that are very, very low resistance, 0.33 in this case here when I traced out this circuit. There's another slot. It actually doesn't have a resistor in it, and that's right here on the board. You see there's a resistor here, but there's a place for another resistor right here. And so I upped the current to 750 milliamps on all of mine that were 500. And again, since I solved the heatsink issue, I haven't had a failure, so I'm getting a lot more light out of those. There's another reason that you may not be getting a lot of light, is, I'll show you right here. The lenses that come on these let's see here. What did I do? Okay, let me just take this off. Okay. Now, do you see the difference in those two lenses? One of them's a little cloudy, the one on the left, and then the other one's clear. Now, these are both 45-degree lenses, and in fact, that's what, if you look on the label for this guy, in fact, all of mine are 45-degree illuminators, and they come with 45-degree lenses on the LED. But this one right here, when you compare the light output, and you have to, of course, see it through your camera because you can't see it with your eye, this one has about half the light output of this, and it's because of that cloudy lens. I took a unit that came with these cloudy lenses and just changed it for these lenses and tested it with my camera, and I got like literally twice the light out of the illuminator just by changing the lenses. So I've since learned to be very careful when buying these, and I bought all these off of eBay, is to look for the cloudy lens and don't buy those. If you have a question about it, you probably want to ask the seller before you buy it. But the photo often shows either a clear lens or a cloudy lens, and definitely don't buy this. The light output on these guys is just barely beyond the visual range. So if visually you can't see through that, then neither can the infrared. It's going to be blocked just like visible light is to some degree. So yeah, stay away from these. Okay, so I've taken this one apart, and unfortunately I don't have one to show you that has a burned out LED, but I'm going to try to show you how to repair that. First of all, you got to determine which one's which, but I've got this wire disconnected because I wanted to show you the current just to show that it does indeed have. Let me set my meter up here, and let's get a little power to this guy. Okay, I've got power, and let's see, I need to get this guy set up for amps. Okay, it's on the 10 amp range. I wished I had like maybe a 2 amp range or a 1 amp range on that, but this will work. There. Okay, about 760 milliamps on this guy. And I don't know if you can see the LEDs slightly glow red. Okay, so now we know this one's actually a functional unit, but let's see, let me disconnect power here before I do something bad. So if you wanted to find out which LED has burned out, and it's only going to be one, because as soon as one LED burns out, since they're in series, they're all going to go off, but only one's going to be bad. And the simple way to do that, first let me connect this this wire back up. Now then, let's plug it back in. Okay, reapply power. And block the sensor, photo sensor. Okay. So now you should be able to hopefully see that they're come on. The slightest amount of light gets in there and it quits. All right. So I'll just hold my finger over it. Okay, to find out which LED is burned out, just take yourself a piece of copper wire, bend it so that it goes over the LED. And now again, all four of these are good, so I'm actually showing you the opposite. When you short one of these out, okay, it's going to go off, and the other three are on. But if I had a burned out LED, the opposite's going to happen. I would go around the board and short out one by one each LED until the other three lit up. And then you know you're on the correct LED, the one that has burned out, when the other three light up. So let's say, for example, it would look like this. The other three are lit. Again, I'm taking my finger off of that, and it's too much light. But the other three are lit and one is off. So this would be my bad LED. And to replace it, let me get this thing unplugged. Okay, you're going to have to pry it off the board because these things are soldered on. And you can do that just by simply cutting the two connections, and then take a screwdriver and get under it, and it'll come off. It'll come off in most likely every one I've taken off comes off in two pieces. Okay, it comes off. It comes off in two pieces with usually. Okay, so this is the actual heat sink that the LED mounts on right here, and this is its case and its lens. So when this is all put together, it's going to be like this. Okay, and so you cut the leads off and pry this thing off. And again, it may come off in two pieces, it may come off in one. But what you're trying to get to is just get down to the solder pad. And then you can, unsolder the leads that are left on the board and clean off anything that needs to be cleaned off. Now, since I don't have an actual board to repair, I'm going to simulate that by putting an LED on this board. And what I use to repair it with, since you can't solder those things on, I just mix up a little bit of JB Weld. That's the easiest way to go. So let's do that right quick. Okay, so now we're going to pretend this is our board that we're going to put the LED on. And let's say it goes right here between, this is where I want to mount it right here. So I'm going to put a little bit of JB Weld on here. And I'm going to put the LED on it. Now then, what you're going to do next is solder each side of this down. You may have to go back and forth as you're holding down on the LED to make sure that it gets fully seated on the board. So you've got your epoxy under it. You're going to go solder here, you're going to solder here until it fully seats down on the board. And I'm not going to do that right now because I don't want to ruin an LED. Okay, so the JB Weld is an insulator. I know a lot of people think that it is a conductor, but it's not. It's an insulator. You can look under the JB Weld website under their FAQ section, and it'll specify that JB Weld is an insulator. So don't worry about getting too much on there, or if it touches another circuit or something like that. It's an insulator, so nothing to worry about. And the one thing I would say that if you do have a little bit of run out on the board, you might want to wipe it off, but you could always go ahead and put your lens on there. And because the JB Weld will not stick to this plastic, so that'll guarantee that anything you did get on here would not affect with putting the lens back on once it hardens. So that's really all there is to making the actual repair. Now, the LED itself, the IR lights that I'm using are 850 nanometer, and that just means that it's the light itself is infrared, but the LED, you'll see it glow red because of being 850 nanometer. If you want to be totally covert with your lights and your cameras, you want to go up higher. You have to get up to around 950 nanometer, somewhere up in that range. So the thing I couldn't identify was exactly what the lens was on the original LED. I know the illuminator itself is 45 degree, okay, because that's that's written right on the label. So but I could not identify exactly what the angle is on the lens of the LED. And I know that these lenses that go over the LED are 45 degrees. So couldn't identify the exact LED that was used. So what I did was I bought 60 degree LEDs. And it turns out that these things work as well or possibly better. I think they're actually better than the original LED. Because I've compared the light output of these 60 degree, with the lenses on the LED to the original LEDs, and this 60 degree was actually better. So if you want to look for these, you can get these for $1 or less off of eBay. And what you want to look for is 3 watt 850 nanometer, unless you're wanting to go totally covert, then you'll go up to the higher range, but 60 degrees. So 3 watt, 850 nanometer, and 60 degrees. And like I said, they're pretty cheap, so this is an easy repair and economical repair, so give it a shot. The current that goes through here, if you wanted to make 750 milliamps be consistent throughout all your illuminators, you'd have to add another resistor across here. These are SMT resistors, which I didn't particularly have any, but I did have some 1 ohm resistors, discrete resistors. And so those that came with only 500 milliamps through the board, I wanted to up them to 750, so I added an additional resistor to get the amperage up. And like I said, I've had these up for 2.5 years now and have not had another failure because I've solved the heat sink issue. I'm going to do another video on that, but right now I'm just showing you how to repair it. So one other thing I wanted to mention is these again are 45-degree IR illuminators. I had a situation in my backyard where I really wanted to broaden out the light a little bit, and so I tried a couple of other lenses. I'm talking about these lenses. I bought some 90-degree and some 120-degree lenses. Now the 90-degree lenses didn't work with a flip. They caused rings to be projected, so it was really ugly. But the 120-degree did work pretty good. So here I've got some 120-degree lenses, and they're going to look the same as the 45-degree. But when I added 2 of these to the existing 45-degree, so I put 2 120-degree and 2 45-degree lenses. Well, what I ended up with was a pretty good distribution of light across my backyard. And so I'm really happy with the 120-degree lenses for that particular illuminator because I wanted the light spread out. Now the others, they're still 45 degrees because I wanted to, like the 2 in my front yard, the cameras shoot down more into the yard than the street, but yet I can still see the street. So I added a couple of illuminators that actually shine out into the street so that I can capture cars going by or people. So those are working really good. Just leave them as 45 degree and get a good beam out into the street from my house. The other thing about illuminators is if you have worked with cameras very long, you'll find the spiders love your cameras. They're attracted to that IR light. So if you wanted to turn off the IR light in your camera and then mount the auxiliary illuminator nearby your camera, the spiders will, be less attracted to your camera. So that's another reason for having auxiliary light. Just don't use the light built into your camera. But that's basically it on the repair. I will do another video on how to heat sink these guys so that they stop failing. And that's it for now, so I hope this is helpful. Bye.